Thank you, Hal. If everybody would pass their papers to your left to my right side, and Isaac is going to pick them up, and we'll do a drawing a little bit later. I'd like to introduce Jim Bates from MapR. Jim is going to be talking about machine learning time series databases. MapR is one of the leading big data Hadoop companies. Thank you, Jim.
All right. I'm not going to find my presentation, so bear with me. All right, well, thanks for coming out. So my name is Jim Bates. I'm a solutions architect for MapR Technologies. I started my career in the data space many years ago, doing transformations of battlefield networks, taking off-the-shelf routers like Cisco 2500s, putting them in a rucksack, jumping out of an airplane with them, and seeing if you get a data shot up on a single-channel TACSAT. Over the years, that's evolved quite a bit to some of the things that we do nowadays. But for the last 3 or 4 years, I've been embroiled in this transformation of this Hadoop space and some of the things that are going on. The MapR is kind enough to let me go around the different places and pick up the bill for all of my travel and things like that to come and talk to you guys about different aspects of open source technology. So I do like to start a little bit, just tell you a little about who MapR is and kind of that company, because I've enjoyed working for them. First off, it's you guys have probably heard the concept of Hadoop before. We're a top-ranked distribution of Hadoop. There are a couple of differences that we bring to the plate. One is a POSIX read-write file system, true multi-tenant capabilities, a lot of cool things. But what it kind of sums it up is being able to do, land 200 million files a day into your system without blinking an eye. Being able to do 14 million metadata operations per second without blinking an eye. Being able to scale to thousands of nodes and do multiple applications, production, batch, real-time, all in the same cluster. But we're also a top-ranked distribution of NoSQL. So one of the aspects we bring from a NoSQL perspective is true real-time capability, zero administration aspects of it, scalability to thousands of nodes, and completely integrated with security all the way through the stack. But being able to do this on the same system as you're running all your other types of batch operations. And then lately, we've been recognized over the last year or so with some of the things we've done for SQL on Hadoop. So being able to pioneer new open source aspects of it and bring that software to the community. But today, the things we're going to talk about, we're going to talk a little bit about time series data in general. Time series, what is time series data? Talk about a basic workflow, that's common across the landscape today. Talk about what happens. So you've got your machine learning going. Well, how do you also interact with that non-data science user, the BI guy, and those types of tools? How do you feed those tools with that same database you put together to do analytics? Take a little bit deeper dive at OpenTSDB. TSDB stands for Time Series Database, and some of the things that's come out in the last year in the advancement of that project. And then finish up, and throughout this presentation, actually, there'll be some links to some references to some resources to help you get training, more information about particular topics, and that kind of stuff. That's all free. So, time series data, right? We all deal with time series data all the time. The weather data, web clickstream data, product data, stock trades. And so the benefit, the purpose of time series data and the benefit of storing it in a time series databases is one, so you can analyze that aspect more easily at higher scale than you could with traditional RDBMS architectures. And we take a look at some of the different use cases, different aspects, right? Whether it's IoT sensor data coming in, there's a lot of explosion of all these different devices. Whether you're talking about, one of the common ones I've had to deal with lately is pumping systems associated with oil and gas industries, right? Where you've got trying to figure out what's going on and to keep those pumping systems from failing, because if an outage goes out, that's like $1 million a day. So, bringing in that data, pulling it in to take a look at it, so I can figure out what some of those issues are beyond just the standard, vibrations are going up on the engine and on the pumping system. Being able to understand that, well, with increased temperature and increased humidity, the condensers don't work as well, the corrosive compounds aren't as cleaned out of the system as they would have otherwise, and so it starts to pit those blades and increases those vibrations more frequently and causes it to fail faster. Being able to get that information and be able to take a look at that requires you to do deep learning. And that learning is done, typically speaking, when you look at the aspects of bringing that data together, you're going to get a much faster or much more accurate assessment by using more data than spending all your time trying to find a more accurate algorithm. But in this case here, right, there's all kinds of different use cases across, from operational behavior analysis, preventative maintenance, and being able to pull that data together to be correlations of different types of events, so I know when to schedule maintenance beforehand, what procedures I need to change, and how things are working, so that I can enhance those the operational downtime and uptime, so I don't have issues with taking things offline. There's a lot of aspects that come to play here. Some of the changes that are happening with this IoT aspect of it, and these different sensors, and kind of what's driving some of the machine learning aspects of these different components. Ted Dunning, who was originally, we were going to try to have him here, but he was not able to make it, is our chief data scientist. He's actually a VP on the Apache Software Foundation. And he's got a nice walkthrough talking about the upside down internet, the changes that's happened, and how IoT is changing kind of the cost and the distribution of data in the internet today. Also talks up here in the corner, he also talks about some of the concepts we're going to talk about with OpenTSDB. Now, if you look at a standard kind of workflow, right, this is your workflow. As I said, so the machine learning aspects we've been doing for a long time. There's not really some of the things we're doing aren't new. We're just having to do it at a much higher scale than we've had in the past. So you've got different types of data sources. It comes in, we have to store that data, right? You've got different types of operational aspects of it, and you've got the reports on the end. And you got all these people here that are dealing with touching this process in different places. So it can be a bit of a cumbersome aspect to get all of this working and to keep it working. But if you look at some of the aspects that are going on, going on today, so as I said, the volume is going up. Storing that data, how much data we want to hold into it, the different types of format, how fast that data is changing. It used to be that stuff wouldn't change very often, but in the last couple of years, the JSON formats, the Parquets, the Avros, all of that data is changing much more rapidly. And being able to store that data and access it's becoming much more expensive from an operational standpoint, from a skill set standpoint, and just from a flat storage standpoint on traditional systems. The batch processing aspect of it. So over the last couple of years, the trend is being pushed. It's not going away. What used to take a quarter now needs to happen today. What needs to happen today needs to happen this hour. What happens this hour should happen this minute, right? That time frame, that push to get things done faster, get more real time, get closer to those decisions, is happening across the industry. And that shift is happening all the way up at a business level. So instead of having those reports and those points of those checkpoints, if you will, that would happen where you would change your business flow, your decisions on what you were going to do. You would have these monolithic decisions that would come in, and then you would build the plan on what you were going to do next. That's shifting to a series of small, continuous decisions that are constantly changing the flow of the direction of what you're trying to do. Does that make sense? All right. And then the reports aspect of it. So one of the things we'll touch on is feeding this aspect of reports over here. How do we get closer to real-time reporting? How do we have more, how do we shorten that data action cycle to be able to pull in reports? Astro is a good example of that. We saw that a little bit earlier, some of the things that they can do. But what are some of the other aspects, some of the other alternatives that we can look at to try to shorten that data action cycle and get more of those reports out quicker? So when you kind of go over the challenges that we have here, right? So we've got existing systems aren't well suited to store high volumes of this time series data. When we go through and look at trying to create different keys and some of trying to create what a time series database would look like, hopefully that'll make it a little more clear. But basically, when you try to put this time series data in a relational data model of existing systems, the churn and the change and the different types of format is a constant shift, and it holds back how quickly you can get your value out of that data you're looking at. Cost-effective, so what are the things we need to do, right? We need to have cost-effective or reliable ways to pull this in, be able to adapt it quickly so that we can shorten the data action cycle. We need to be able to be agile enough to bring on new bits of information, new data streams, new sensors, weather data, all that kind of activity, and be able to pull it into our models in a much more efficient fashion with fewer people. Now, when we look at deploying this kind of thing in an existing workflow, this is a common workflow that we deploy this out in the several different use cases, several different places I've worked on this kind of stuff today. You've got all the different sensor aspects of it coming in. You feed that into OpenTSDB, and we're going to go through what that actually looks like. What are the software components of that? How does it feed in? How does it get persisted to disk? We'll go through that aspect of it. But this is a high-level aspect of how it gets aggregated into the system. So one of the cool things I like about working with MapR is, as I said before, it's got that read-write POSIX file system, tier 1 storage platform, as well as a complete Hadoop distribution for open source aspects of it. So I can actually just stream data into an NFS aspect of it. One of the cool things about working on this platform in general is a lot of times with Hadoop in general, everything is like a dump truck. To be able to get your tool, whether you're talking about small data sets of a 100K file and you're just taking a look at it, you got to use the same dump truck tools to kind of move your data around and take a look at that aspect of it. But with MapR, I can actually use my land the data in a cluster and run an R script, pull it up, do a set awk, clean the data, just edit the data straight. Since it's a POSIX read-write file system, I don't have to do anything special. So all the small tools that I'm used to working from a perspective, whether it's Python, R, those types of things for the smaller data sets when I'm just playing around with it from a development standpoint, they work just like they would on my laptop or anywhere else. And when I turn around and want to apply the large-scale aspects of it, then I can use the large-scale tools associated with Hadoop. But in this stack here, right, we've got the data that streams in. It's persisted into the platform. We'll talk about how it gets persisted into HBase or MapRDB. And then we use something like Spark as a common aspect for being able to do the machine learning aspects. And we also use something like Apache Drill to do some of the aspects of reporting on the far end. The Spark in and of itself has exploded over the last year and a half. So one of the things that it's really, from a machine learning aspect, one of the things why it's become such a, an exciting tool to use is it's done it, when you look at all the other types of tools that exist out there for processing streaming data, for processing machine learning, Spark has done and the community of Spark as a whole has done a really good job of pulling in the different types of libraries like R, mlib, Mahout, the different aspects you would use for recommendation engines, for correlation, for those types of anomaly detection. It's done a great job of pulling those different types of analytics into the system and applying it to a distributed file system so we could do the distributed storage and distributed compute. Like we were talking about earlier with our last presentation, having all of that data in a distributed storage and distributed compute with something like Spark allows you to push that out and ask the questions across all those nodes and maximize that data where it's sitting on the hardware platform or the storage platform. But Spark, Spark in and of itself has something called Spark SQL, which is a great tool for looking from an SQL perspective and feeding and doing some things with that. SQL, it has been around for 30 years. It is one of the most used and most prevalent skill sets that exist out there. But from a standpoint, Spark in and of itself is great for working within the framework of Spark SQL is great for working within the framework of Spark, but from looking and being more agile to taking the data sets in their raw form and getting those into the BI tools, the analytics, the reports for the executive, those types of things. Apache Drill is an open source project that's done a great job in the last year or 2 years. It's come to a point where it's very mature, allowing you to do that. Being able to take flat, so you've got all the aspects that you, from a standpoint of flat files, CSV files, JSON files, being able to look at all those data sets inside a Impala or something like Hive, being able to look at data sets that are in something like a HBase, being able to look at data sets inside of MongoDB or Cassandra, or just data sitting on your laptop outside of any of those particular systems, and pull all of that information together with one SQL interface and feed that into your existing SQL tools for analysis in an ANSI 2003 SQL standard language. It's a very powerful tool for shortening what used to take months to go through and take new data and get it to those individuals to take a look at. Now it takes just a couple of weeks. And these are some of the aspects of it. So giving SQL a new life in this big data space, Apache Drill's done a great job of that. If you haven't looked at it, take a look at it. It's gotten a lot more mature in the last year and a half, and it's in production use in many different places in the country today. One of the cool things about it, it's very scalable, it's very fast. From that standpoint, when you load things into, when you read things into disk, it tries to keep everything in memory as it pipes flying through the system, so the distributed aspect of it. So everything kind of looks up into that DAG as it goes and processes. But here at the bottom, if you can't, when you pull the slides down or take a look at this later, you'll see that it scans the data from wherever it exists, whatever storage plugin, pulls it up, and then works through from an SQL query processing, be able to push that through and get your answers. So a lot of things that you can do with different types of actions, you can do with drill, but it's all ANSI SQL interfaced aspects. So you don't have to go and learn Java, you don't have to go and learn different types of skill sets. In a couple of minutes, you can just take files, land them in your distributed file system, put them in your laptop, and then start processing from an SQL engine perspective. We're not here to talk any more detail than that, but there's a lot of cool tools in that aspect of it. So from going back up a little bit, so we talked a little bit about this framework right here. So the data comes in, we've got the different data sources, we land it, we're going to land it in OpenTSDB. We can use Spark aspect to process it, and to get to a point where we got our answers that we're looking for. But the question here is we scale this aspect of it up and want to process millions of these data points per second. Getting that right is one of the big challenges with dealing with these different sensor platforms in the IoT environment. So we'll take a little bit of a moment for the rest of this presentation and really focus on time series databases in general, what they constructed look like, some of the tools that exist, and some of the places you can go to get started taking a look at time series databases in general. This is a great book. It's written by Ted Dunning, once again, that chief data scientist, chief application architect for MapR. It's available for free. The one thing I like about his book, there's about 8 or 9 books that are available for free, from machine learning concepts, anomaly detection, securing security today in Hadoop, real world solutions in Hadoop, time series database. There's a lot of different books. What I like about his books, they're about 120 to maybe 150 pages long. So by the time you get done reading it, it's not out of date yet. So it's not a 400-page book where it takes you 3 months to be able to get through it. You can actually sit down and read through it in an afternoon, maybe 2, and get some really good information out of it. So this is that OpenTSDB. This is what it is, right? So what you have here, basically, anyone, are you familiar with HBase or no? Anyone familiar here? Are you guys familiar with the NoSQL stores in general? Columnar-based NoSQL stores, right? So what you have on the back end, right? You have a NoSQL store that you're going to persist the data into. On these are what you time series daemons. These are our time series daemons. Forgot the acronym for a second. That you're going to use to collect the data, organize the data, and push and persist it into your NoSQL store. It actually takes the place of interacting directly with the NoSQL store. So for OpenTSDB, you actually, all the different servers, they connect and push information into the time series daemon. And then the different web interfaces, scripts, different actual reporting engines, right? They're going to pull information from that time series daemon. Now, what does that kind of workflow look like? So, as the data comes in, right, your different sensor platforms throughout the area, we're going to push the data into here, gets pushed into the aspect of it. Now, what does that look like? So you've got the different data sources. It comes into a collector in the time series daemon, and it gets pushed into HBase. You typically have, and this is the original project as when we first started looking at it, hourly accumulator, right? So every hour you want to take that information and kind of condense it and bring it together to one kind of row of information. The reason for doing that, right, is to organize a little bit better. That way, when I pull a row, I can get all the time series aspect for that particular row, and then the renderer will pull that information out at the end for your aspects of it. But when we put this together and first started taking a look at this format here, we only got about 20,000 data points per node per second. And one of the things that we wanted to do is try to increase that speed. Right, we had to find a way to get that speed aspect of it. And one of the things you can do is start. Because right here, the hourly accumulator, as it reads back and forth between the persistent storage, is not actually in the line of processing that data. So one of the things that we do is we started taking aspects of utilizing in-memory storage aspects. So the data sources comes in, it goes to a collector, it goes to an in-memory cache, and in that in-memory cache, it gets processed and pushed to the hourly accumulator that way. It also gets pushed to the renderer for reporting aspects of it. So this allowed everything to happen in memory, vastly increased those particular writes. But of course, when you start dealing with memory, right, you could have failures, so there had to be a restart log. This is what we've put together to kind of make things quite a bit faster. Of course, you can take a look at the code associated with this. It's on the GitHub site. This is another look at that same processing aspect of it. But the process here of pulling that data in, getting it processed, pushing it to disk, all of this information is actually explained in a nice, white, there's 3 or 4 chapters associated with this in Ted's book. He goes through quite a bit of details on the different steps associated with this, why the challenges with the relational databases in general, and why the OpenTSDB was a better solution in the long run for a lot of the time series data sets that we're seeing today. So let's take a look at, so we have this architecture here pushing the data in, but what does that data look like? What does a time series database look like? What is that information? How is it organized? What do those keys look like? How do I read those? How do I read that data? How do I process it? So one of the cool things is if you're using a relational kind of database, right? The column names are kind of part of the schema. They're not very flexible. If you're using that NoSQL column restore, it's much more flexible for being able to to build changes into it. So as your aspects of your time series database changes, as some of the well, actually, let's bring it up here. As you take a look at it, this is a relational store here, a typical relational database. So we would have a time series ID associated with our one of our values. We've got a timestamp that may be associated with a particular key, and then we've got values. Now in the relational models, every one of the values is going to have to be a column in that database. That's very burdensome from a standpoint of, because different sensors, different aspects of it, that shifts quite a bit. So you'd have to have a different table organization structure for different types of sensors, and that as opposed to just using an ID and being able to point it that way. If you look at some of the aspects from a standpoint of OpenTSDB and using a NoSQL store in the back end, one of the cool things I can do is that the columns themselves can actually become valuable bits of information in storing my data. I can actually have time shifts at that point. So I still have my series ID, I've got my timestamp aspect as my row key, but each one of my columns here can actually be an offset to that. So at 155100, right, I had one value come in at plus 3, plus 7, plus 11. If I have a little bit of inconsistency and drift associated with some of my timestamps when they're coming in, when I get collected, because when you're dealing with sensor data in general, it's not always exact on when that data shows up, and those timestamps aren't always repeatable to be exactly every 3 milliseconds I'm going to get that, or every 5 minutes it's going to show up on time. So that actually can shift quite a bit. This kind of eliminates some of those issues because I can just create a new column when I need to drop it into the system with whatever the current shift is from the row I'm currently dealing with. So this allows that to be very flexible and adapt to the different changes that are natural in the IoT market without having to do a lot of painful coding, and it's much more persistent because it breaks a lot less often. Now, an interesting aspect to kind of walk through of this in quite a bit more detail than what we're going to cover here today is H-based key design with OpenTSDB. It's a nice, it's about an 8-10 minute walkthrough specifically around how the key design, the different aspects of it, how it works from an OpenTSDB standpoint, talking to H-based. And it's a pretty nice little walkthrough around that aspect of it. So we've got our aspects of it here, that's great, but this, depending on how many columns and how many shifts that we have coming in, this can start to get a little bit cumbersome at that point, right? This, if I've got thousands and thousands of columns here because of some of the things that are going on with my offset here, then that can be quite a bit slower. So some of the things that we like to do is go back in and compress that. So you can compress all the values associated to that particular row in one column in themselves, and that way, when you can go in and pull when you want to pull a timestamp, you can pull all the values for that row at one time for that particular group of sensor data. This makes this much, much faster from a standpoint of being able to pull that data out, pull it into your algorithms, pull that aspect of it, and process it. So from a scalability standpoint, you're able to scale to much, much faster rates. Now the other cool thing is it's still a little bit flexible, right? Because if you have a couple of ones that come in a little bit later, you've just finished your compression operation, you don't have to throw them away. You can still stick them in there as an offset, and you can, as long as they're manageable and not that many, you can pull both the compressed values and any other remaining offset ones that didn't get through that compression process. So it allows it, once again, to be more flexible. So as you're building an application to do machine learning around some of these, or any application associated with time series databases, it's much more flexible, it's much more resilient, it's less likely to break, it's less brittle. If Ted was here, he would go through this in much more detail. I don't know this one, so I'm going to skip this slide. That was one of my hidden slides here. Now that's great. So we've got our data points coming in, right? It's working pretty well, but how fast is it, right? And how much can we optimize it? So one of the things is, in its current form, right, just out of the gate, it can scale to millions of data points per second, being able to take millions of sensor data readings, push them in, pull them into the system on a per second per node basis. But that's great if you don't have 10 years worth of data you have to analyze. As I said before, a lot of the times, in order to be accurate, you want to take all the sensor data over years and years to be able to build your models around. And taking that information and loading it into your system to process it means that, at an operational standpoint, if I'm doing 1,000 operations per second, and that's okay, I've got to be able to do 1,000 times that if I want to be able to load the data to be able to do my modeling. Otherwise, I'm going to have to wait a whole year to load my couple of years worth of data, right? So if you have a large data set, you need to find a way to be able to pull that in at a much higher rate so that you can load it up and do your modeling on that aspect. So how do we do that? How do we take the data that exists, right? We've got years and years of data. We want to be able to pull that in a fashion where I don't have to wait a full year just to load the data and take a look at it. So one of the things that we did was we took that same kind of blob storage that we were doing for the inline aspect of it. We went down here and we actually created a blob loader to go directly into the HBase. This allowed you to load the data sets from the existing archive at a much faster rate. We're talking on the order of 25 million operations per second per node at a linear scale, that aspect of it. So at a 4-node cluster, doing 100 million operations per second, at an 8-node cluster, doing 200 million operations per second. That allowed you to go through and do 15 years worth of data in a couple of hours, right? Be able to load that aspect of it so we can start doing our modeling and taking a look at that from a standpoint of machine learning. The details on that aspect of it, actually, if you want to go through and read a nice, a couple of pages on that exact process, once again, all the details behind the code, pull down the code from GitHub, step through it yourself, that's available. The link's down here. It goes through the details of setting up that exact cluster, 25 million operations per second, an example data set that you can go with using LogSynth to generate the data set associated with that to be able to pull it in. So if you want to take a deeper look at that operational aspect of it, as a nice write-up around this aspect, and you can pull it up and read through that. All right. So, wow, blew that about 30 minutes. From the standpoint, one of the cool things that MapR brings to the table, right? One of the things that we contribute back is we have a tremendous amount of on-demand training that's all free from a standpoint of being able to go up, learn about some of the different ecosystem components, base aspects of Hadoop, advanced H-based programming, being able to do things with Hive, Spark, Apache Drill, all the different aspects of understanding those architectures and writing your first application to writing some advanced applications, row key design, things like that. There's on-demand training associated. It has labs. You can download those. It's all free. Let's see. We also have all the free resources that are available. Like the Spark book, that's one that just came out last month. It's a pretty good read. I would recommend it. The blog site and all the different aspects of the videos. I blew through that much faster than I intended to. Probably should stop and ask for some questions here and there. Do we have any questions at this point in general about MapR, about the OpenTSDB in general, some of the places this may be in production?
Yeah, I got a question. You may have discussed this and I missed it. So the hourly accumulator, is that taking that, when that data all gets put into the format that you were talking about as far as, say, compressing them into...
Yeah, so that's the purpose of the hourly accumulator, is kind of that blob builder at that point, to be able to take a look at the data that comes in and then create and compress that on an hourly basis into one one system at that point. That way, when I go back and read that information later on for whatever applications, that's going to come out much faster.
Yeah, so that's your way to get that data in a format that you can quickly process it, model it, and whatever.
Yeah.
Thanks.
Any other questions?
Yeah, the original Dunning talk, I think I saw part of it, was using compression on time series data to detect for anomaly detection, the heartbeats and things like that. And so I guess I'm wondering, does MapR do wrap any functions in there for that, for specifically anomaly detection type time series?
Yeah, so once again, the MapR in of itself doesn't. The OpenTSDB is not part of MapR from a standpoint of that. What we saw on the screen here from a standpoint of building a time series database is not part of the direct aspect of MapR offering. We do have a quick start around that aspect, but we don't have any, we don't have any vested IP, I guess you would say, intellectual property around that. Ours is in the overall data platform in its entirety. So being able to do the aspects of OpenTSDB, HBase, across the MapR data platform, so all the aspects of Hadoop, as well as being able, if you wanted to, like SAP HANA. SAP HANA can run on a MapR node and actually use the MapR file system as its persistent storage in the back end, right? That's one of the things that we can do that you couldn't do with something else, right? Or if you wanted to run a MySQL server and put that in the data behind the MySQL server into the MapR platform, outside of the Hadoop aspects of it. Those are the things that we've offered to the table, bring to the table.
I guess the part I was particularly interested in is he talked, and this might have been his talk and not functionality he provided. He talked about how compression, as you showed in one of your screens, but how the anomaly detection, doing anomaly detection based upon the compressed data set.
Yeah, I mean, if you have a specific, so if your ranges are all supposed to be within a certain area, you don't actually have to pull all the values out of that compression to be able to figure. You can actually do analysis based on the contents that you think are supposed to be in that compressed blob, right? So from that standpoint, depending on what your normal aspect of it is, you can do anomaly detection around each individual point and pull that out and do it that way. But at the same time, you can also do it around the actual blob to see which blobs are of more value, to be able to say, oh, this blob has got some weird things going on. I need to, this is the one I'm going to push up to the queue, and it needs deeper look, right? So from that standpoint, I think that's what he was referring to with that aspect of it. That make sense? Yeah. Okay.
Now the Apache drill, when you brought that up, it sounded a lot like BI tool type of.
Yeah. So if you look at like Spark SQL, so Spark SQL fits well within the Spark framework. It's much more attuned to machine learning workflows, whereas Apache Drill is ANSI SQL. So you've got your windowing functions. You've got aggregations. You've got very deep subquery correlations. Push downs into your different databases, but it's really designed for more of your BI workflow and your data discovery process for pulling in new data sets. That's why I kind of put both of them up there. So you get the Spark framework, which is great for your machine learning, and the BI guys, when the executive comes in and goes, why can't I have this report now? Like, all right, give me a couple hours, I'll give you a report, right? So the Apache Drill allows you to do that without having to, with just one guy, a power user sitting down, be able to pull in new reports and do some things that are pretty amazing in a very, very rapid fashion. Other questions?
Actually, I was curious about that one slide you had. I think the head architect, Ted or whatever, said the internet turned around. So is that basically from the idea of we send a little bit of data into a server and then we get a whole pile back, as opposed to now there's these servers collecting massive amounts of data?
Yeah, so I mean, this is a great talk. I really enjoyed it. But this is kind of your standard internet, right? We had very, very, very expensive, very, very, very powerful boxes. And you have all the different computers and routers and DSL boxes sitting at someone's house, where you're pulling the internet feed down to those locations. Now, these boxes are vastly more expensive, but when you look at the and vastly more powerful. But when you look at the total cost and cycles spent, it's still overwhelmingly in the millions and millions and millions of these devices. This is still where most of the cost is, because of the sheer number and volume of those devices that exist. The upside down internet is because we have we're going the other direction. Well, now we have these small cheap devices where instead of taking large pipes that get fragmented to smaller and smaller pipes, we now have all of that same traffic workflow but going up the other direction. We have all the different devices all trying to push information now all back up and aggregate that to one location. And it goes through and kind of lays it out in a much more articulate fashion than I do about what that means from a cost perspective, what that means from a performance perspective, and kind of what that means from a math perspective when we look at how we process data and how it's going to change. Question? Anyone? All right, well, I can't forgive you. I didn't get in until about 3 o'clock this morning. I think you asked the first question. That's a screwdriver. It's from Apache Drill.
Oh, well, thank you.
All right.
Screwdriver?
And then at the back there, there's a couple of giveaway things. There's some bottle openers. There's some brochures on the free training. There's a couple of brochures on some of the books that you can download around anomaly detection, time series databases, and so forth. Right. So some of the information is also, you can just grab that on the way out.
Lee Cole here?
Yeah.
You're next.
I was expecting, but what the heck. All right. I have to tell you that back in the day, I used to teach, and we had auditorium rooms like this. And this is the most unusual one. It sort of levels off at the back. So the sort of students that wants to hide in the rear of the room, this is a perfect room for it. Congratulations. Okay. Back in the day when I had my own shop, I had a rule, no meetings over an hour. Obviously this is going to be more than an hour at this point. So I could either get you to all stand up and do jumping jacks, wake up. So the rule is going to be if anyone snores loud enough that I can hear them, I will come give them a whack on the head, all right? Okay. I am not going to talk to you about how to do large data analysis. I'm not going to talk to you about different tools and techniques that are available. I'm going to talk to you about an application, okay? A little bit of background. 10 years ago, there was a small startup that was doing risk management software for the stock markets, based out of New York. For some foolish reason, we put R&D together here in Colorado. In 3 years, we were watching roughly 1/3 of the shares traded in America every day. So, I know a little bit about the trading arena. I'm not going to claim to be an expert. I'm going to claim to say that I was doing risk management, and I was the sort of person that would look at the traders and see when they were doing things they weren't supposed to do. You've heard stories about the high-frequency traders and how occasionally they're not the most ethical people on the planet. My job was to catch them, all right? The company was bought by NASDAQ 5 years ago. I left 3 years ago, but I still know a little bit about the business. Okay. What we're talking about is quantitative trading, algorithmic trading, programmatic trading. This is because it's numbers, okay? Everyone here is a very data-oriented person. Everyone here is a very numbers-oriented person. And everyone knows the stock market is made up just of numbers. Therefore, oh God, what just happened to all my money? Okay? As much as you think the stock market should be predictable, all of us who have training in any of the mathematical sciences, physical sciences, chemical sciences, we're used to saying, all right, we're at this point. Therefore, because of the laws of physics, nature, logic, whatever, it should evolve in this normal direction. The stock market doesn't do that. You've heard the term stochastic. That means if you're at that point, it will evolve in a random direction. Guess what? The stock market is worse than that. Because if you're at that point, and you think the market's going to go zig this way, and you trade based on that, your trade has changed the market, and it zags, okay? So, a couple of things about quantitative trading. Advantages, disadvantages, some terminology. Investing versus trading, because there is a huge difference, all right? I'm not talking about investing today as much as I'm talking about trading. Time frames, cost, and liquidity, which has a huge impact on all this. Advantages, you take the emotion out of the system, all right? For those of us who saw the flash crash, all right, and you saw the market go down 570 points in 5 minutes. In my shop, I was actually at my desk hollering out the numbers to my crew saying, it's down 300, it's down 400, it's down 500 over the course of minutes. We saw it because we had servers in the market. Part of our normal operations, IT operations, we had things that were looking for load, for CPU usage, and suddenly our market data servers were spiking. Okay, market data servers that normally run at 10 or 15%, were at 45 and 50. What happened? The market goes down. How much money did you lose during that crash? You didn't lose anything unless you traded. Okay, because it came back up in 5 minutes. What caused it? Hey, anyone remember? It wasn't program trading. Anyone remember the cause? It was a response. Program trading was a response to the cause. Anyone remember the cause? Some guy living with his parents outside London who did 50,000 E-Trade contracts, or E-shares contracts, all of which had to be hedged, meaning if you think you're going to sell a lot, somebody has to be able to buy a lot. And the program machines were doing the hedging, and they did the hedge in 20 minutes. And things like Procter & Gamble, which was trading at $29, suddenly was trading at 2 cents. The program machines that said, I know this is worth $29. Maybe I'm wrong, maybe it's worth 25. Saw the 2 cents, jumped right in. Program trading is actually what brought it back in 5 minutes, okay? All right, disadvantages. Oh, sorry, back to the advantages. If you have a strategy, you've got a clear set of rules of what you're going to do. You can be mathematically optimal for certain senses of the word optimal. We'll talk about that in a second. Disadvantages. Over 70% of the market is currently algos. You are not competing with mom and pop around the corner. You're competing with somebody's machine, programmed by a couple of PhD physicists, mathematicians, engineers, someplace. The optimal assumptions, really, the great mathematical derivations of the optimal trading algorithms miss one thing: cost. It costs to trade. If you're a high frequency trader and you're doing millions of shares a day, you can trade for pennies a share, fractions of pennies a share. Anyone in this room? We're paying like $7.99 for whatever the trade is, right? Okay, that cost actually has a lot of impact. Markets change. Okay, yes, back to the, no matter what you think your assumptions are, where did my money just go? Okay, investing versus trading. Investing is longer term holding. You actually think the company is going to go up or down. You're willing to buy or sell and hold it for a while. There is a concept called universal portfolios. A gentleman named Thomas Cover from Stanford did the research, published this back in the 90s, okay? There are lots of derivations of this. You can take an arbitrary set of assets, stocks, long positions, short positions, bonds, whatever you want to talk about. Equally weigh them, and every step in time, you can sit down and refine and go through and how you're going to get an optimal portfolio. It's guaranteed to be better than any single stock or any single asset in that class that you used. Absolutely guaranteed, except for costs. Doesn't take into account trading costs. Large firms, if you're a Fidelity or if you're a Vanguard and you're your own brokerage, and you can go out and you can trade for 1/10 of a penny a share, and your clearing costs are 0.3 of a penny per share, you can get to this optimal portfolio right away. A lot of the reason that people say index funds are optimal is because these large groups that can do the index funds don't have the costs, and they can drive this. They take advantage of that. Trading is a different story. The classic example of trading is exchange arbitrage. Exchange arbitrage is, I found this stock over here that I can buy for 110 cents and I can sell it over here for $99.90, okay? Right now, immediately. With all the algos in the world, these opportunities don't exist very often. They still do exist. 5 years ago, I was bringing a new trader online. They were doing all their market data analysis. They saw this difference in price between NASDAQ and NYSE, New York Stock Exchange is NYSE, sorry. They will call themselves the New York Stock Exchange. They get very upset when you call them NYSE. Everyone in the industry calls them NYSE. They saw a difference between NYSE and NASDAQ. They said, obviously your data is wrong, because there's a price difference. No, that's actually something you were supposed to trade on, go do it. But it's very, very rare these days. Statistical arbitrage is more common, and it's certainly more of an aspect for machine learning. Statistical arbitrage, you have some sort of stock. Average price is 100, but it fluctuates over time. It might, if we assume it goes up 5%, down 5%, the trick is to buy it when it's down 5% at 95 and sell it when it's up 5% at 105 and you made 10 bucks, right? Buy low, sell high. Everyone knows that. The problem is, while you're doing this, you have money at risk. You have your $95 investment at risk. And if the market were to go up or to go down, you're toast. Better statistical arbitrage is to make it synthetic. Let's say you have two stocks, A and B. In the idealized version, they happen to be in the same industry, they happen to be roughly the same price, they happen to have roughly the same size company. They're both roughly $100, but they fluctuate as well. Your synthetic is A minus B. If A minus B, because of the fluctuations, is greater than 0, that means A is greater than B. Oh, you sell A. You buy B. What have you just done? You sold at 105, bought it at 95. You now have a $10 profit. If your statistics are right, and over time these two come back to an average of 100 each, when they get back to that average, you buy the one you sold and you sell the one you bought. And you've just made $100, or made $10. How much money have you had at risk? Nada. You actually made money on the initial trade. That is what quantitative trading in the big leagues is about, okay? The other thing to point out, if the market were to go up or to go down, if you're assuming that A and B are correlated, if the market goes up 10% while you're holding these stocks, what happens? Nothing, because you're just looking at the difference between the prices. Goes down, what happens? Nothing, you're looking at the difference between the prices. Your synthetic is stable when the market changes. So you're looking for correlations. The whole big data game is to look at correlations between different stocks. You can extend this to different asset classes. You can look at bonds, options, futures, options on futures, commodities, foreign exchange, all sorts of different things. There are 36,000 listed stocks. Listed, not the over-the-counter blue book or pink sheet stuff. Listed stocks in America. If you just look at pairs, 36,000 squared is a very large number. There's a lot of different possibilities. But you don't have to limit yourself to two. The more classic operation on the street right now is called index arbitrage. In this case, the synthetic is an index. The S&P 500, which trades under the symbol SPIDER, or SPY. NASDAQ 100 trades under the Qs, okay? In these cases, you have either 500 S&P stocks or 100 NASDAQ stocks that have some sort of weight. And because you are very good, and you have machines looking at the market data feeds, you know exactly what the price of each of those 100 in the Qs actually is right now. and you can do the sums, and then you can look at what the price of the Qs is. And if the Qs are higher, you sell the Qs, buy the 100. Other way around, you flip it, okay? The very large hedge funds, the very high frequency people do this all the time. It's almost a guaranteed profit if you are fast enough. The issue is, if you are fast enough. I left this industry about 5 years ago. The time for a light signal to travel between NASDAQ and NYSE was 6 milliseconds. It is currently 300 microseconds. They've switched to lasers. Okay. But the big players are not doing, they're going to focus on the spiders, the indices, the opportunities in general for someone who wants to trade go back to all the other stocks. There are lots of different stocks out there, lots of different asset classes out there. They correlate in amazing numbers of ways. Large data analysis really, I mean, you are not going to be able to sit down and do a dimensional analysis for all the different asset classes, long and short positions, in different currencies, in different markets, in different exchanges, and get all the possibilities, all right? There are large multi-trillion-dollar asset firms like BlackRock that try to do this all the time, and they just focus on a small set. Oh, the other thing is correlations. Correlations vary over time. So if you're looking at a 1 minute correlation versus a 1 hour correlation versus a 1 day correlation versus 1 week, 1 month, you'll get different pairs that are reasonable to trade. The issue, of course, is cost. The fact that you have a trade that might make money doesn't mean that you have a business, okay? You have to pay costs. There's clearing fees. Somewhere down the line, you have to pay for the market data. If you're doing this on a monthly basis, you can read the paper, all right? If you're doing this, if you're one of the hedge funds in New York doing this, you are probably getting live data feeds. Live data feeds cost on the order of $500 a month per venue. There are roughly 24 venues in America. You're paying $12,000 a month just to get access to the raw data feeds. And oh, by the way, because each one thinks my way is better than everyone else's. Everyone has their own format. You have to write custom data handlers for each one, okay? You can get away from that. There is a consolidated feed mandated by law. All the different exchanges get together, send their messages to one central point. The central point says, this is the best buy offer, this is the best sell offer. It's going to be several hundred milliseconds behind. If you're trading on the order of minutes or hours, that's not an issue. If you're trading against the hedge funds, you've been burnt, okay? Liquidity. The other thing is, can you actually trade? I said there were 36,000 stocks traded in America every day. Or sorry, listed in America. Of those, roughly 800 are actively traded. By actively traded, I mean more than 100,000 shares a day. Okay? A lot of the stocks you'll run into don't get traded that often. Can you be profitable with them? Sure, as long as you're looking at a strategy that's looking at months or weeks intervals. If you absolutely positively need to sell that stock in the next 5 minutes, you better be talking about an actively traded share, okay? Time frames. The longer the time frames, the more external influences can impact things. Again, if you're doing a synthetic and things are going up and down together, that's not the issue. The issue is what happens if the correlation varies. All right? What if you're dealing with airline stocks and suddenly the CEO of one of your airlines has a heart attack and goes away for 4 months, which happened recently, right? The longer your time frame, the more you're exposed that way. Shorter time frames are less risky, but the costs are high. Everyone here recognizes that exchanges are no longer floor traders, right? Exchanges are data centers. There is no exchange in the state of New York. The state of New York passed a law to get some tax money, taxing every trade. And every exchange in the state of New York moved across the river to Jersey. okay? They are all data centers in Jersey right now. You go outside, you go across through the Holland Tunnel, you come up, and within 10 miles, almost every exchange in America is right there. To buy a rack in one of those exchanges is about $35,000 a month. Plus you're paying about $12,000 a month for market data fees. Then whatever you're paying your quants. Okay, that's what you're competing against if you're doing the high frequency stuff. I don't compete high frequency anymore. I find the things that no one really cares about and try to go there. All right. Trading is competition. Again, you're competing with the algos. You're competing with machines, you're competing with people who hire PhD mathematicians. For those who are mathematicians, I apologize for this. Mathematicians are easy to beat. Mathematicians don't understand engineering realities. I actually had some mathematicians, when we told them that we could take 2,500 messages per second. They sent 2,500 messages in the first millisecond, nothing for the next 999, and didn't understand why there was a delay in some of the messages. Okay. The engineers tend to be the better ones. But a lot of this right now is machine versus machine. If you've ever seen the old cartoon Spy versus Spy, this is what's happening for a lot of the algo market. Trading fees. If these high frequency people actually don't go through a brokerage, they work with a brokerage that clears their trades, and they actually borrow the brokerage's identifier going to market. The identifier is called an MPID, Market Participant Identifier. Merrill Lynch gives out thousands, not thousands, hundreds of these to high frequency traders, and those traders go direct to market as a result. Their fees are pennies. And for a lot of the exchanges, if you are adding liquidity, the exchange will actually pay you to place your trade. If you take liquidity away, they'll charge you. There are actually strategies that have nothing to do with trading, nothing to do with the value of the underlying securities, nothing to do with the difference between the two. They're just trying to get the fees that the exchange will give for adding liquidity. The flip side is the large firms have to make a large profit. If they don't make big money, they're going to die. They have spent hundreds of millions of dollars on equipment, staff, algorithms, code. I know lots of firms that were making more than $1 million a day. A lot of them went under. The other thing is firms blow up all the time. If your algos are wrong, and oh, by the way, algorithms change roughly every 6 weeks because the correlations change almost that frequently. Everyone here know the name Knight Capital? All right, cool. Knight Capital had a box in some old racks, was powered down. And somebody, for some reason, power cycled that rack. The box came up. It was a year-old algorithm. Oh, I love the laughter. Year-old algorithm. For 45 minutes, this algorithm ran, connected to the New York Stock Exchange. The folks at NYSE see this and go, this is just all wrong. What's going on here? They call Knight and they say, what are you guys doing? And I says, what are you talking about? We don't have anything connected to that line. Yes, you do. $7 billion in positions in the span of 45 minutes. Okay? Bad positions because it was a year-old algorithm. They spent the entire day unwinding those positions, taking the ones that were long, selling them, taking the ones that were short, covering them. Over the course, they lost $478 million because of 45 minutes worth of trading. That killed the company. They were bought by a group called Genco. Ignoring index arbitrage and similar things. I'm not even going to, okay, you've heard a lot about the unethical things on high-frequency traders. The issue right now is called execution arbitrage because I can make a trade faster on this exchange than this exchange because I can get there in 100 microseconds faster than anyone else, okay? I'm not even talking about that. That's a rigged game. I'm actually talking about something that might make sense for the rest of us. Anyone who's doing correlations between different asset classes, different stocks, they change all the time. Those correlations change with time. And frankly, if you were to find a relationship that worked and you started to trade it, that correlation would suddenly go away because your trade is reversing. And maybe someone else sees it. Maybe someone else sees that somebody is trading those stocks and they jump in too. Okay? The correlations go away all the time. No one in the industry, there was one person in the industry who actually found a correlation, thought it was really cute. They were an academic, they published a paper about it. Everyone in the industry came by and slammed him. I mean, no, you don't do that. You trade it. You don't tell people about it. You trade it. Okay? It won't last that long. But these correlations, they come, they go. You folks know the data analysis. You can do the correlations yourselves. I'm just giving you an application. Stochastic. For any set of initial conditions, the next step is random. This is going back to what we said a moment ago. Yeah, not in trading, okay? If you make a trade, you change the direction of what was going to happen. It's not just random, it's now anti-random. It goes against whatever you wanted. Prices change in response. Others notice, correlations disappear. But look at the number of things we're talking about. 36,000 stocks. That's just stocks. Double whether you're taking long and short. Now, options. Options are a lovely little field. For everything there's an option that has an option, you have both a price and a time frame. There are 600,000 options listed in America today. Okay? Now you get into commodities, futures, foreign exchange. The number of possible combinations is essentially limitless. Yes, for the mathematicians, it is finite in some sense. However, it's computationally infinite. The issue is the cost. If you need to go after a very small difference, you need very small costs. That's something that can be done if you're a large shop, a brokerage, something like that. If you're a peon like myself and you're now paying $7.99 per trade on E-Trade or whatever, it better be a fairly good and strong correlation. All right. And that's it. I'm sorry. Probably ran a little long. Any questions?
So you said trading a correlation makes the correlation weaker.
Yes.
I mean, it would seem logically that it would, if there are arbitrage opportunities, the more it's traded, the less those arbitrage opportunities would be. But the correlation would become stronger because more and more people would think that.
Yeah, but the correlation you're looking for is something where the two stocks that will go in sequence will eventually converge, okay? The difference is there. What your trade does is effectively reduce that difference. It takes the price of this and reduces it.
Oh, okay. So it's not, you're saying the arbitrage opportunity.
Right.
It's not the correlation.
Right.
Okay. That makes sense.
Does Bridgewater Capital use a lot of this?
I'm sorry?
Does Bridgewater Capital do this?
Bridgewater Capital, I'm not familiar with them in particular. I will tell you that almost every hedge fund in North America does a strategy based on synthetics. Again, if anyone here from Oppenheimer or Janus? No, okay. These are mutual funds. Mutual funds have to hold long positions. They can't short anything. So the idea of a synthetic where you buy one and sell the other doesn't work for them. Hedge funds can sell and have a short position. Any hedge fund is going to use short positions so that instead of having the $95 in our example at risk, they're going to take a profit right away and just see if they can keep their costs down so the profit doesn't evaporate. Any hedge fund of any skill is going to have lots of short positions. Other questions?
How do you know what nobody's paying attention to?
How do you know what nobody's paying attention to? If I knew the answer to that, I would not tell you. This goes back to the guy who got beat down, okay? It varies all the time.
How many people are trying to play that game? Or is that everybody's trying to play that game?
Anyone who knows the market is trying to play that game. There are people that invest long-term, long positions, buy and hold. That's investing. That's not trading.
And
if they're trading the market,
investing on fundamentals.
Right, right. If you do a Graham and Dobbs, sort of normal fundamentals investing, that's investing. That's not trading. I'm talking primarily about trading.
Thank you.
Okay. Now, with investing, you can do universal portfolios, and you can come up with an optimal one over time if you don't mind absorbing the costs. But frankly, the large funds, Magellan funds, the Vanguards, Fidelities, whatever in the world, can do the same thing, and their trading costs are much lower.
So I guess the fundamental question, is it worth it for any individual person to possibly even try anything in the stock market, or is the system so systemically different from that you just don't?
If you are trading a correlation, if you see a correlation and it's real, as opposed to, oh, look, I see a correlation. If you're trading a correlation and it's real, it's worth doing, okay? The market would not be doing all this if that wasn't true in those cases. The issue is, what correlations are real? What correlation, okay, if you're doing index arbitrage, if you're doing index arbitrage, frankly, if you're fast enough, it's a guaranteed profit.
Yeah.
The problem is, the guy who was fast enough last week will be beat by the guy who's faster this week. And that person will be beat by the person faster next week.
But faster has changed the nature of the entire system, because now there are other things happening that have nothing to do, perhaps, with the original.
If you're talking about execution arbitrage and index arbitrage, yes. But if you're talking about correlations between stocks longer term, different story.
Yeah, understood. Thanks.
What kind of tools can average for this room person use to find correlations?
If you can go out and you can get freebie data out on the web. If you want daily or hourly, you can actually screen scrape Yahoo. Okay, although I will tell you that Yahoo is now detecting too frequent a query on their stocks and will lock you out if you're not careful about it. The data sets are public domain. I mean, knowledge is out there. The question is, why would you bother with 10-year-old data if the correlation you're looking at is only good for 6 weeks? One more and then, sorry, two more and we'll call it, because I'm running way too long.
So the correlations, I mean, if you say 70% of the trades are, by these trading firms that are also running algorithms. So the correlations exist because some other correlations exist, which, my question is, does it end up being cyclical at any point? Like, these correlations exist for a while until they, until too many people exploit them. And those cause others to exist until too many people exploit those. Does it ever come back full cycle? Or does that tend not to happen?
Okay, again, this goes to, if I knew the answer to that, I'm not sure I would tell you. But arbitrage is basically looking for an inefficiency in the system. On the exchange arbitrage, you're looking for some sort of pricing efficiency for some silly reason. Okay. The correlation arbitrage, statistical arbitrage, you're looking for some correlation. You may not have a priori definition of why that happens. You just see that it's there. Like a lot of data, big data analysis. Okay. You want to take advantage of it.
But will it tend to occur again in the future once it's been exploited to the point it's no longer useful?
I will tell you that a lot of the high frequency traders have a set of algorithms they use, several dozen, each tunable. On any given day, oh look, it looks like algorithm 12 is going to be effective. We'll actually spend real money there. They run them all virtual. We'll spend real money on these 6 today. Do those sets ever come around? I actually was not legally allowed to look and see. I had obligations to not reverse engineer anybody's trades. Okay, it was a small company. We eventually got bought by NASDAQ. Amazing regulatory issues when you are bought by a large federal institution like that. Okay, we went from a startup of 75 people to a large federally regulated entity that couldn't change your pricing 1 cent without prior SEC approval that would take 9 months. Okay, so I'm limited as what I can actually look at in their data set. But could it come around? Sure, there's no reason it wouldn't. Is there a guarantee, or is it worth waiting for? I don't know that I would really want to wait that long to find out.
So it's essentially as random as the price movements.
Again, think of the stochastic, and then think of a little worse than that. You had a question?
What are your thoughts on Bitcoin?
I'm sorry?
What are your thoughts on Bitcoins? What are your thoughts on Bitcoins?
A cost on a big trade?
What are your thoughts on Bitcoins?
Oh, Bitcoin. Thoughts on Bitcoin. I know NASDAQ is actually running an experiment to use Bitcoin to do the record keeping. I think the blockchain technology for keeping record of who owns what stock is going to revolutionize a lot of things. That being said, I'm not sure it's going to impact the high frequency trading simply because it takes too long to verify a block. But I think for general accounting purposes, it's going to be revolutionary in ways that I really can't understand yet. But I think it offers a lot of possibilities, and I apologize for running over.
Lee, I have a couple of questions
Oh, sorry.
For you.
I didn't do it. I wasn't there.
No.
I never even met the room.
I read in the Wall Street Journal, I think a couple of months
You want
ago,
to take
for
the
the past
presentation
4
off
or
this? If
5
so, I need a
years,
memory card. You want me to just plug this
if
in?
you had bought a
Plug it in?
simple index fund, that would have outperformed the overwhelming majority of hedge funds.
Yes.
So how does that happen? If the hedge funds actually have all of these purported advantages, why would a simple index fund of a basket of stocks outperform the overwhelming majority of hedge funds? Not all. There are a few hedge funds that will outperform it, but very few.
I'll go to the 70% comment, okay? The 70% of the trades right now are algos. What's happening is the hedge funds are fighting hedge funds for that little penny difference in the stock price. They see an inefficiency in the market, pricing between one exchange or correlation between shares, and they're fighting for that. And they go out and they place their orders, and what most people don't recognize, how many orders on the market are actually executed? What percentage? Any guesses? 20%. Any other guesses?
1%.
1%. Any other guesses?
100%.
100%. Any less extreme guesses? Roughly, okay, on a really, really, really good day, 1% of the orders placed execute. Most of the orders are not orders, okay. Do you guys know what the difference between a market order and a limit order is? Okay, market order means get me the current price on Microsoft, whatever it may be. Limit order means I will buy Microsoft at 103.25, period, okay? Retail does a lot of market. The high frequency people don't take the risk of losing those pennies because somebody might change the price here. They will say, what's the limit order? And a lot of times the limit orders are good for 100 milliseconds, 500 milliseconds. It's not an order as much as it is a probe. Is anyone out there really willing to trade at this price right now? And when you've got algos competing with algos, you've got people that are going, I actually think that Michael may be trying to buy Microsoft, so I'm going to place a few orders high, see if I can sell it to him at a higher price, and see if I can get away with it. It's the algo versus algo work that is beating these guys down. They're still paying fees for all these trades.
All right, so it's basically turned into a battle of the algorithms, and us small people are at a huge disadvantage if we
Right.
try to compete
Well,
in the currently structured market.
There's a couple of gray hairs out here. You guys remember Core Wars?
Yeah.
Okay, it was basically a game on a mainframe where you could get, you'd have a program that was trying to eat everyone else's section of memory. Okay. Algo versus algo was a lot of Core Wars. Now, if you just want to sit and hold, you can do a universal portfolio type approach, and you can make money. I think someone said that Donald Trump got some number of millions of dollars from his father when he started. If he had just put it in an index fund, he would be worth more today than he is worth now.
That's right.
Okay.
It's
That's
amazing.
based on an S&P 500 index.
Now, okay, he's also gone bankrupt several times, and I will give him credit for, once you go bankrupt, coming back up. That's hard. But yeah, if all you want to do is sit back, you can do that. Do you guys remember the book Black Swan?
Yes.
Okay. Talib. His he actually runs a fund. His strategy is 90+% of the fund is in bonds, earning almost nothing in interest. The other 10%, he takes the money from the bonds and he does these outrageous options bets. Okay? 9 years out of 10, he underperforms the market dramatically. 2 months ago, he made $1 billion in one day.
So he loses for 9 years, quite a bit of money actually.
Yep.
And most investors don't have that type of volatility tolerance. But 1 year he makes that back and a whole lot more. I have another question, and it's regarding spoofing. How many people have heard of spoofing? Yeah, so the whole market now is a battle of algorithms. Essentially, either the best data scientists, the best quants win, or you start to cut corners and engage in spoofing. And I think that that's happening a lot more than people think. And I think just a few days ago was the first ever criminal conviction of somebody caught spoofing by the United States Department of Justice.
It wasn't the first.
Oh, was it the first? Okay.
There have been lots. part of my job at F10 was catching those people. There's things called baiting the book. I can place an order that says, if Microsoft is trading 100, I'm going to place an order that says, I'm interested in buying at 103 for the next 10 microseconds. That's a legal order. Order goes in, goes down the wire. Everyone looking at the market data sees, oh look, he's trying to buy at 103. It's only 100. I bet you I can buy at 102 and sell it to him. Now the guy who placed the false order is selling at 102. It's called baiting the book. Okay. There's a lot of strategies like that. They are completely illegal. It is against the law to place any order on the market that you do not intend to execute. That being said,
That's tough to prove intent.
A, tough to prove. B, if you get caught, you pay a fine. C, the fine ain't that big, and a lot of people consider that a cost of doing business. Does it happen? Yes. Is it legal? No. Is there part of the issue is the law says that the clearing firm is responsible for catching these people, and you as the clearing firm must use your best judgment as to whether or not this is baiting the book. There's no finite criteria. Well, this is my trader. He gives me hundreds of millions of dollars a day or a year in fees. I will talk to him. I will slap his wrist. I will lower his margin intraday. But I probably won't cut him off unless there's a real problem, or the SEC comes down on me, or the exchange comes down on me. 7 years ago,
Clear conflict of interest.
7 years ago, the New York Stock Exchange found 10 traders. We talked about cancellation rates. When you cancel an order, don't execute the order. They found 10 traders that had 99.995% cancellation rates or worse. And they actually could not kick them off. What they did is they raised fees for those people. That shut down the firms because their trading strategies could not absorb the cost. Is it straightforward? Yes. Is it a game that is easier to play if you are in the racks with several tens of millions of dollars worth of equipment to do the high frequency strategies? Yes. Does that mean that the rest of us can't play? No. There's millions, billions of different possible combinations, correlations that you can find and take advantage of. Are you going to make a lot of money with it? Your chances of making a lot of money in the next week are roughly the same as your chances of winning the lottery. Doesn't mean you'll lose money, doesn't mean you want to guarantee it.
What's your risk exposure?
Depends on your strategy. If you do the synthetics, your exposure can be almost negligible. It's just the cost of the trades. One more, and we should probably
Does it have
close this.
an impact on the real economy?
I'm sorry?
What impact does it have on does this type of arbitrage trading have on the real economy?
Trading guarantees, trading like that guarantees that if you actually want to sell or buy a given security, you will get the best price in that range, in that moment that you want it, okay?
There's a large fund absorbing.
Most of the exchanges now are making their fees off of trading fees, not IPO fees, okay? I think that's an issue. That's a personal view. If in terms of liquidity, without these people, liquidity can be horrible, okay? When I first got into it, somebody at a clearing firm said, "You see this trade over here, 5 shares at $12,500 a share. What's my risk on that?" I said, "Well, it depends on how many shares traded today." 5 shares at $12,500 a share. If that trade had broken, the bank was on the hook to go find 5 shares of this $12,000 stock within 3 days. That was their risk. Okay. Some things don't trade very frequently. With the high frequency stuff, basically, if you want to sell a spider or buy a spider, it's like microsecond pricing, and you know you're going to get the best at that point in time, and it's going to be able to happen.
I think the answer is it's a trade-off. I think the argument is definitely true. It adds liquidity, but at what cost? I think it definitely distorts the market. It's tough to measure, though.
Some people, Mark Cuban was recently in the press talking about trying to put a 1 second limit on holding the stock. You couldn't buy it here and sell it there in the same microsecond. 1 second to hold. That will slow things down. Anything that would increase the fees. If the SEC were to increase their fees, that would slow it down. It would make things less liquid. You might not be able to sell as rapidly. Where's the trade-off? That is not an engineering decision. That's a societal decision.
Lee, thank you
All
very
right.
much.